Hey guys, this is Mr. Bennett, and this is Unit 14, video number 1. We're going to look at variables and gas laws. So we're going to start off by talking about what we already know about gases based on previous units. The first thing is that they all have the ability to change their shape. We also know that they have the ability to change their volume. And because of that, we know that they have the ability to be compressed. Or another way of saying that is the opposite of compression would be to expand. So they're different from solids and liquids in that solids have that fixed shape and fixed volume. Liquids have the freedom to change their shape and but the limited volume, meaning their volume is fixed, whereas gases have the ability to change both shape and volume, plus they can be compressed or they can expand. Now we know that when they collide with objects, they create pressure. Right? Pressure is all about those collisions, and we know that if we increase the temperature, that's going to increase their kinetic energy. So basically, if you increase the temperature, you increase the number of collisions because they're moving faster due to more kinetic energy, which means you increase the pressure. So that's stuff that we've already talked about in the past. Okay, so now as we start talking about gas laws, we need to talk about the rules. And the first rule is that for any variable, the units to begin with are the units that you must end with. So for example, if you're dealing with pressure, volume, temperature, mass, or even the number of moles, whatever units you start with, those are the units you must end with. So for instance, if you start with atmospheres in pressure, then your answer needs to be, or needs to use, units of atmospheres. If you have volume and volume is being measured in milliliters, then you need to end with units of milliliters. Okay, you can't change units in the middle. Okay, the only exception is temperature. Turns out with gas laws, it is super important that all of your temperature units must be in Kelvin. You cannot do the calculations with Celsius. So that means that if they give you a number in Celsius, you need to use that Kelvin conversion, which is the temperature in Kelvin is equal to the degrees Celsius plus 273. So make sure that before you plug in numbers in any of the gas law equations, you convert temperatures to Kelvin. That is super important. Okay, so let's move on here. Let's talk about the two different gas laws that we use in this unit. So first of all, we have the ideal gas law. The ideal gas law is PV equals nRT. That's the equation. Now, we're not going to actually use this equation, but you do need to know it. And what does that really mean? Well, you don't really have to memorize this as much as you just need to know that this is on the back of your periodic table. In fact, both of these gas laws are on the back of your periodic table. Okay, so if you forget the gas law, you can always look it up there. So this is the ideal gas law, and it turns out that we can take this and we can actually rearrange it and change it around, and we can create what's called the combined gas law. Okay, so here's our second gas law. P1 V1 over T1 equals P2 V2 over T2, and all this is saying is that the initial pressure, volume, and temperature, right, is tied mathematically to the final pressure, volume, and temperature, meaning that if we change the pressure by a certain amount, then the volume and temperature will change accordingly, and that they'll change in a way that is predictable, meaning that the ratio of pressure, volume, and temperature is always going to be the same. So if we change one, it will change the others by a specific amount. Okay, and you can predict that amount. So let's go briefly over what these letters stand for. So if we're dealing with the ideal gas law, it has actually all the letters. P is going to be pressure, right? And the units of pressure that we use are things like atmospheres, kilopascals, torr, what's another one? Millimeters of mercury. Remember, all of these are also on the back of your periodic table. As far as volume goes, V is for volume, and the units of volume that we can use are going to be things like milliliters, liters, centimeters cubed. Okay, so those will be our typical, also cc's. That's another one we could use. N stands for number of moles, and those units are obviously moles, so don't really need to go over those. R is weird. It's actually a number. It's called the ideal gas constant, and it has a value that constant. Constant, there we go. It has a value, actually has two different values depending on which pressure you're using. There's one value based on atmospheres and there's one value based on kilopascals. But it's a number, so you don't really need to worry about this as much, but that's what that R means. It's just a number that keeps gases, that makes the equation work essentially. And then the last one is T. We know what this is. This is the temperature, and we know that units of temperature are going to be degrees Celsius or Kelvin, but for gas laws it must be Kelvin. Okay, you can't use Celsius in your equations. Alright, so those are the gas laws. These are what the letters stand for. So let's talk about how we use the combined gas law. So let's scroll this down a little bit here. So using the combined gas law, again, you don't have to use the ideal gas law. We're just going to use the combined gas law. So for any question, the formula contains 6 variables, right? Because you have P1 V1 over T1 equals P2 V2 over T2. And so there's 1, 2, 3, 4, 5, 6 variables. But your questions will generally give you 5 variables and ask you to solve for the 6th value. So here's an example here. It says, given 300 milliliters of oxygen at negative 73 degrees Celsius and 225 kilopascals, what will be the new volume if the temperature rises to 27 degrees Celsius and the pressure was or is 150 kilopascals. So let's start off by identifying which is which. So it's saying that we have 300 milliliters of oxygen. Well, that's V1. Okay, and we're at negative 73 degrees Celsius. Okay, and we're at 225 kilopascals. So if you're asking how did I figure out where to plug these in, it's all about the units. Milliliters is a unit of volume, Celsius is a unit of temperature, and kilopascals is a unit of pressure. So it's all about identifying the units compared to the variable that they measure. Now if we move on, it says what would be the new volume. So they're asking about the new volume, right? So that's our question. So I'm just going to go in here and put a little question mark, because that means that we're going to be solving for volume 2. It says if the temperature rose to 27 degrees Celsius and the pressure is 150 kPa, kilopascals. Okay, so normally I would be ready to go. I could just plug in numbers and get an answer. However, remember, we can't have temperatures in Celsius. So we need to add 273 to this, which is going to give us 200 Kelvin, and we need to add 273 to this, which is going to give us, that would be 300 Kelvin. Okay, now we can plug everything in. So we're going to use this equation here, right? And we're going to plug in, so our P1 is 225 kilopascals times V1, which is 300 milliliters, all over, let's see, 200 Kelvin, and then that's going to equal P2, which is 150 kilopascals, times V2, which is what we're solving for, so that's why I wrote the variable itself down there, and then on the bottom 300 Kelvin. Okay, so let's do a little bit of reduction before we start actually doing any math. So first thing I want to do is I'm going to get rid of these zeros. Okay, I'm going to this one over here, actually we can do 150 goes into 300 twice, so we'll change that to a 1. Okay, and so what we get is we have 225 times 3 divided by 2 equals basically V2 over 2, right? And based on algebra, we know that if we just solve for V2, if we can get V2 by itself, then we'll have our answer. So what I'm going to do, before I do any math, I've already reduced, but before I do any math, I'm going to get V by itself. So V2 is being divided by 2, so to get it by itself, I'm just going to multiply this side by 2, and it's going to be 2 Kelvin over 1 kPa, because I have 1 kilopascal on top, and I have 2 Kelvin on the bottom, so I'm just going to multiply by the reciprocal essentially, or the opposite, and I'm going to do the same thing over here, so 2 Kelvin over 1 kPa. Now the reason why I did it this way is because I want my units to cancel out as well, right? I want to get the correct units in the end. So on this side, the 2's cancel out, the Kelvins cancel out, and the kPa's cancel out, so I'm left with just V2. On this side, my Kelvins cancel out, my kPa's cancel out, my 2's actually cancel out, right? The 1 on the bottom doesn't really matter. So all I'm left with is 225 times 3 milliliters, or 675 milliliters equals V2. And that is my answer. So all I did was I used algebra to get V2 by itself, and I got my answer. So the real challenge is, can you identify the variables, can you plug them into the right spot, and then can you do some algebra to solve? Okay, make sure you complete the whisk, and we'll see you tomorrow.